Yep.
Okay, this is what the graph y equals x squared minus 5 looks like regularly. But when you make it a reciprocal, which is when you put 1 over it, you have to figure out how to draw it, and it's really hard. First of all, you have to find the invariant points, which are -1, which are when the graph crosses -1 and +1. Because the reciprocal of +1 and -1 remains the same, so the points don't change. You have to look at the x-intercepts, which are where there will be vertical asymptotes and the graph cannot cross.
There, give it to me, Jill.
Oh, I'm it.
So this is what the graph looks like as a reciprocal. It can't cross the vertical asymptotes, which are at the x-intercepts. Horizontal asymptote, which is usually at the x-intercept, the graph cannot touch either. However, it can approach it and come close, unlike the vertical asymptote. This is one of the more complicated examples because there are no x-intercepts on the graph. We need to find the minimum point and then find the reciprocal, because xy on a normal graph translates into x1 over y on a graph with reciprocals. So we find the minimum point, we translate it into the maximum point on the reciprocal graph. There are no invariant points on this graph and no x-intercepts. So there are no horizontal, vertical asymptotes or invariant points. So this is your graph you end up with. This is the simplest version of where y equals x plus 6, so it's just a straight line. First, you mark your invariant points, so when y equals 1 and -1. Your x-intercept, and you draw your graph. And that's your graph. This is an example where the graph only has one x-intercept, so there's only one vertical asymptote. So keeping in mind the invariant points, you draw your graph. And this is your graph. Keep in mind that you never cross the x-axis because it is your horizontal asymptote. On your original graph, the points are xy. Your final graph, your reciprocal graph, those will be your coordinates.